In this video, you will learn how to balance chemical equations. In a chemical equation, there must be an equal number of atoms in the reactants and in the products. Currently, in the equation above, we have an uneven number of elements in the reactants and in the products. When balancing chemical equations, we aim to make them equal. The first rule of balancing a chemical equation is that we cannot change the subscripts or add extra molecules. All we can do is change the coefficients. Look what happens when we add coefficients. The numbers of atoms in the reactants are now equal to the products. However, the second rule of balancing a chemical equation is to reduce where possible. All the coefficients here are divisible by 2. Finally, we have a reduced balanced chemical equation with equal numbers of atoms on both sides. Keep watching this video to see more examples of how to balance chemical equations. In these next few examples, I'm going to show you some strategies when solving chemical equations. So I like to start by first writing down the atoms that can be found on each side. So on each side we have aluminum and we have nitrogen. So write that down first. Now count up the total number of atoms of each element in the reactants and the products. In this case, we have 1 aluminum, 2 nitrogen in the reactants, and 1 aluminum, 1 nitrogen in the products. So if we add a coefficient of 2 in the products, this will give us 2 nitrogen and 2 aluminum. But it's still not balanced. We have a difference between the aluminum in the reactants and the products. But if we add a 2 in front of the aluminum, that gives us 2 aluminum and 2 nitrogen in the reactants, and 2 aluminum and 2 nitrogen in the products. In balancing this next equation, we will use a very similar strategy. So we are going to again identify the different types of elements found in the reactants and products. In this case we have iron, Fe, and oxygen, which is O. Now we have to count up the total number of atoms in the reactants and the products. So we have 1 Fe and 2 O in the reactants and 3 Fe and 4 O in the products. Since we have lower numbers in the reactants, we know we need to start there. By adding 3 coefficient in front of the iron, we now have 3 irons in the reactants to match 3 irons in the products. And if we add a 2 coefficient in front of the oxygen, we now have 4 oxygens in the reactants to match the 4 oxygens in the products. Remember to start on the side that has the lower number of atoms. So in this next equation, we're going to get a chance to see when you have to add a coefficient in the products and a coefficient in the reactants. So we start out by again writing down the different atoms we have. In this case it's tin, oxygen, and hydrogen. So in the reactants we have 1 tin, 2 oxygen, and 2 hydrogen, and in the products we have 1 tin, 1 oxygen, and 2 hydrogen. So the only thing out of balance here is the oxygens, so let's start there. In the products we will add a 2 as a coefficient in front of the H2O, giving us 2 oxygens, but it does unbalance the hydrogen. So now we look at the reactants and we can see that adding a 2 in front of the H2 will give us 4 hydrogens, balancing the equation. This last equation is both our most complicated one and nice because it shows us that sometimes you really shouldn't reduce even though it seems like you can. So let's first write down our atoms. We have carbon, oxygen, and hydrogen on each side. And then we'll count up the total number of atoms in the reactants and the total number of atoms in the products. So we have 1 carbon, 3 oxygen, and 2 hydrogen in the reactants, and 6 carbon, 8 oxygen, and 12 hydrogen in the products. So we always look at the lower numbers first. So we'll start out with the reactants, and we'll just go ahead and add a coefficient of 6 in front of H2O, hoping that we can balance the hydrogens, giving us 12 hydrogens. Now they match up, but we also have more oxygens as well. So now we have a total of 8 oxygens, which does match up with the 8 oxygens in the products. So all we have left to do is match up the carbon. We know we must need a coefficient of 6 in the reactants to give us 6 carbons. So now we have 6 carbons to match, but unfortunately this puts our oxygens out of balance. So now instead of 8 oxygens in the reactants, like we originally had, this changes to 18 oxygens in the reactants. So now we need to go look over the products and see how we can balance the oxygens in the products. So, looking at our numbers, the easiest one would probably be to balance the O2. Why do I go to the O2? Because it's by itself. It should be the easiest one to manipulate. So by just simply putting a 6 coefficient in front of the O2, we can change to 18 oxygens, matching up 6, 18, and 12. And we don't reduce because there's no 6 in front of the C6H12O6 compound.